How are you, everybody who is watching this fantastic video? I'm very happy, and I would like to take this opportunity to welcome you into this very moment and interesting moments of learning about electronics, and especially electronics and the electrical workshop practice. Let me take this opportunity to welcome online students who are not physically just connected with me, but also the good news, in this class we have some engineering students who are doing Bachelor in Mechatronics Engineering at Dar es Salaam Maritime Institute, or DMI. These are the very fantastic and actual young engineers in our beautiful country, Tanzania. So we'll join with them, and I would like to appreciate about their love on the matter of 40 of electronics. My name is Olenjolai. If it's the first time to meet me, I'm very happy to have you. And I would like just to tell you that the contents which we are going to cover today actually be focusing on the simulation. We'll be focusing on the theory and the simulation. But later on, we'll be having the hardware implementations of what we are going to cover today. So we'll be just having a minimum theory, and then we'll be just actual that use our computers in order to simulate what you are going to learn in theory. So the requirements for this course is actually the fresh mind and the love of electronics, but also you have to make sure that you have an exercise book, you have a pen, you have a pencil, you have a ruler, because we are going to deal with schematic circuit diagram. But another requirement is a computer, which is actual as a setup of any offline or online simulation software. And these programs, actually, the contents we are going to cover is for the beginner, electronics or mechatronics engineers, or biomedical engineers, or computer engineering engineers, or telecommunication engineers, or even just the electronics and telecommunication engineers. So all of those 6 related courses, electrical engineering, these contents are very important because the circuit which you are going to discuss, they have a part of electrical and have a part of electronics, which means that semiconductor and conductors. Then I would like to ask you to be interactive in this program. Use the comment sections in this video to ask you questions in case you have any. For these local students, I will give them the chance to ask you questions in case that they have any of the questions, because asking questions is a way of understanding. So I don't want to waste much of your times and actually give you a lot of introduction. This is actual, I would like to take this opportunity to welcome you into electronics, and the names of the modules is called electronics and electrical workshop practice. We are in workshop number 8, which is titled as measurements of electrical parameters in series and parallel circuits. So to appreciate the physical students that I have to this class, let me and you who is online greet them. How are you, students? No. How are you, students? Okay. Do you love mechatronics engineering? Yes. Are you ready for workshop 8? Yes. Wonderful. So let us go to the business. So let us start with quick review of the previous workshop, of workshop 7. So in workshop 7, actually, I have taught you about how you can draw schematic circuit diagram of AC power system. AC power system. AC power system. But another concept which I taught you about choice of what? Choice of different testing point, different testing points. Then another concept which I taught you that I didn't mention about testing points in detail, but don't worry because today I'm going to insist it so that it can click in your mind. Another concept which I taught you, it's the choice of measuring AC, measuring what? Measuring instrument, right? And we say in AC measuring instrument, firstly we have AC kilovoltmeter. You remember that? And then also we have AC voltmeter. Then also we say that, I thought that we have AC, what? Millivoltmeter. Also I have talked about AC microvoltmeter. So this is actual the measuring instrument for the voltage in at different points of the AC power circuit. Then I talked about how you can measure currents. I thought that we have AC kiloammeter. Again, students, we learned about AC what? Ammeter. AC ammeter. Then also we have AC milliammeter. Also we have what? AC microammeter. So these are the 8 measuring instruments that we have learned. And I told you that it's very important for you to note them because the choice of the measuring instruments, it's actual, these are just the 2 measuring instruments, just the voltmeter and the ammeter. But it's very important for you to break down the concept because the choice of the right measuring instruments depends on the magnitude of electric parameter that you are going to measure. Are we together? But we say that the one notations or the one of the key point of 40 of AC power system, we say that the AC power source is the one which will indicating to the reader or to the learner that according to the source of power, if it is AC, then that's we call the AC power system, right? And in case of simulation, we say that we have a signal generator, which is this one, which we call TOT alternator, right? And then here we have a sinusoidal wave form. Are we together? Yeah, so that's what we have discussed. But if you do remember that what I have taught you once again, I taught you about almost 5 or 4 important measuring parameters. Hello, 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 hello. Wake up. So I told you about the nature of AC waveform, if you do remember. And then with this nature of AC waveform, we say here it is, we have voltage or we have what? We have current. Then I told you about 4 important parameters in AC theory. The first one is what? Maximum voltage or maximum current. Or in other words, we call it amplitude voltage or amplitude what? Current. Then the next one, mention the next one. Students, mention. Root mean square value. We may have root mean square voltage. We may have also root mean square current. Right? The third one, the peak-to-peak value. Right? We can have peak-to-peak voltage or peak-to-peak what? Current. So then we say that, suppose that this is our sinusoidal. Tell your neighbor, mechatronics is beautiful. Tell your neighbor again, mechatronics engineering is a beautiful cause. So invite him or her to test it, if it is sweet or bitter. So if you have this one, so this is maximum voltage. So positive, negative, right? Then we say the root mean square voltage, it's actually that is here. So for the case, so this it can be is a maximum voltage or maximum current, right? So this one we use the symbol of 40 root mean square voltage. But remember that we don't have negative root mean square voltage. We just have only positive. And that's why we've been using the AC voltmeter, when actually that you don't set the readings properly, you may find that the value of the measured physical quantity is alternating. Why? Because the frequency might be lower, but also what you are measuring is not the root mean square voltage. Are we together? Then I mentioned the force. The first one is called what? The force average. It can be either average current or average what? Voltage. Are we together? But we say that we don't use average voltage or average currents because the average voltage of AC power is 0. And the average voltage of AC current is 0. Alternating current is what? 0. That's why we don't use it. Then I told you that all the voltmeters and ammeters measures what? Measures root mean square voltage or current. Bear that in your mind. Are we together? So we have discussed a lot, but this is just a summary. And if you have enjoyed it, say that, congratulations, my neighbor, for quick review. So we say that in electronics engineering, so this is today's workshop. Hello? In electronics engineering, different electronics or electrical components may be joined together either A in series, B in parallel. So we say that in electronics engineering we may connect more than two or more than two electronics or electrical components, either in series or in parallel for the particular purpose. Right? For the particular purpose. Remember that we don't connect them in series or parallel just for the aim or for the sake of connect them in series or in parallel. Let me just share with you one of the particular purpose. Hello, asthma. Asthma is asthmaing. Class, asthma is what? Let me give you one of the purpose. Why do we connect? Ask your neighbor. Why do we connect electronics or electrical components in series and parallel? We taught you this concept in O level. We taught this concept in A level. We taught you this concept in ordinary diploma. Right? But ask your neighbor, why did we, and we know the formulas, right? Because we may connect either resistors in series or parallel. We may connect the capacitors either in series or in parallel. We may connect the diodes either in series or in parallel. We may connect the inductors either in series or in what? In parallel. Those are the four discrete electronics and electrical components. So ask your neighbor, why do we connect these components in series and parallel? Because what I know, what we have covered in science, how you can calculate equivalent value once you connect the components either in series network or in parallel network. We may also connect batteries or cells either in series or in parallel. That's what we have taught you. So ask your neighbor, why do we connect them in parallel and why do we connect them in series? Ask your neighbor and listen his or her response. Just listen what your neighbors think about parallel and the series connection. This also is your neighbor. Yes, so this guy has to talk in this way, in both sides. Okay, thank you for your discussion. I think your neighbor has told you something. Well, okay. Stop the discussion. Let us continue. One of the purpose of connecting electronics components in series or in parallel is in case of achieving the standard value. Resistors are not made for any values. Capacitors are not made for any values. So sometimes in your design, you might have the value of capacitance or the value of resistance of the resistor, which is not standard. So you need to take it 2 or 3 or more than 2 resistors, either to join them in series or in parallel, or in series and parallel, in order to have the standard value, or in order to have the calculated values that you have calculated in design. Because in electronics, we don't just use the components because we need to use. We use them because we need them to perform a particular function. Okay? So listen, let me just take a simple example of resistors. In calculation, you don't care about the value of the resistance of the resistor. You just calculate, right? For instance, you made in your calculation, you say that you need a resistor which its resistance is 100, let's say that 100, 550 ohm. You have been doing designing, and you are designing a particular electronic system. So in designing, in most cases, we use formulas and mathematical equations to do calculation, right? So suppose that you have done your calculation, and you came up that you need to use a resistor with resistance of 550 ohm, right? In science that we taught you in O level, A level, in the ordinary diploma, you don't care about the value of resistance. You just calculate whether it can be even decimal places or it can be the whole number. You don't care, right? But once now you are thinking about electronics engineering, another thing that you have to make sure that, well, you may use the formulas and the equations that you've learned in mathematics and science to do your calculation. That's fine. That's why we taught you that fundamental concept. But you have to add a value in your mind. And the value that you have to add in your mind is actual that you have to think about availability of that component that you need to use in your design. Are we together? Because in science, or in science, we used to calculate and then we don't care whether the components is there physically or it's not there. Right? So now, what we are adding a value in your minds as mechatronics engineers, you have to think about availability. So the availability now, let me talk about availability. In case of resistors, resistors are not made for any value. Say it loudly. Say resistors are not made for any value. Resistors are not made for any value. Good. So resistors are made in terms of standard values. So it means there is a standard values, and it means that you cannot find a resistor of any resistance or any number of resistance that you know. Are we together? For instance, there is no any standard resistor which its resistance is 550 ohm. Are we together? Are we together? Yes. Let me repeat. There is no any standard resistor, any standard physical resistor, or there is no any physical resistor whose resistance is 550 ohm. You see? So in your calculation, you didn't care, and really you have you should not care, right? So you did your calculation, your design, fine. You have a resistor. You need a resistor with a resistance of 550 ohm. That's fine. But when you go to the market or to the electronics shop, and then you ask the dealer to sell to you a resistor with a resistance of 550 ohm, you won't get it. So you are solving a problem, and then you caused another problem. Are we together? Yes. But that having a resistor of resistance 550 ohm, it cannot limit your design. There's another technique that you may use to supplement your design. Are we together? So if you say that, let me think about the standard resistor whose resistance is less than 550 ohm, and the standard resistor whose resistance is greater than 550 ohm. That might be the first alternative, right? So you may choose either of them, right? So let me tell you the standard. For instance, the standard resistor whose resistance is less than 550 ohm. It's a resistor which its resistance is 510 ohm. Right? Then another standard resistor whose resistance is greater than 550 ohm, but it's nearby, right? It's a resistor whose resistance is 680 ohm. Are we together? Class, listen, watch. So how can you solve a problem? Well, okay, we may use another. So this is the first alternative. You may say that, let me choose 510 ohm, but its resistance is less than what? 550 ohm. What the difference? 40 ohm. You will be lacking 40 ohm. Ignore about the concepts of the torrents first. I don't want to confuse you. Because you may use also the concepts of the torrents. Then, if you say, let me take the higher resistance, right? Of 680 ohm. 680 ohm minus 510. What do you have? 130. So, So do you see now, my friend? He was not listening. Now he is slumbering. Okay. So 130 ohm. So in your circuit or in your system, you have additional resistance of 130 ohm. So that option may fail, may cause. Because remember, imagine, because in most of electronics system, resistor, it's one of the discrete components which you'll find which occupy which occupy the large space of a motherboard, right? So imagine if, for instance, you have maybe in your design you have 20 resistors, and all your calculations, the values that you've calculated, they are not standard. So as well as you accept the actual that the resistance will be less than 550 ohm by 30, then you may cause a challenge. Because, for instance, what if you do that for the 20 resistors? It means your circuit might misbehave. Are we together? Hello? So, the simple alternative, or the second method, we have to think about connecting or choosing the standard resistors, which its values should be less than 550 ohm, and try to think to join them in series or parallel, or series parallel. Are we together? Because here, see, we may join also components in series parallel connection. And we discussed this stuff in advanced physics, in O-level physics, and we dealt with Kirchhoff, if you do remember about those. First Kirchhoff law, second Kirchhoff law. So you're expert in that. But now to find what you've been thinking about using the Kirchhoff, that's the challenge. And that's our responsibility. Are we together? Okay. So in order to have a resistor, or just a resistor with the resistance of 550 ohm, then I will say that, what if I take R1, which it is 220 ohm, and also there is another standard resistor, which I will call R2, which the resistance is 330 ohm. And then I have been told that, okay, so I need just one resistor there. Okay, fine. So I can join R1 with R2. So this is R1, this is R2. Right? Then we have told you that the total resistance, it will be R1 plus R2. So if that's the case, here we have 220 ohm plus 330 ohm. This makes 550. Did I solve my problem? Yes. Yeah. So that's why we connected different electrical or electronics components either in series or in series or in parallel or series. There is a purpose and there is a challenge made that sought to be discovered. Have you understood? Yes. Is it clear? Yes. Okay. Well, write down. So if you want to master about electronics, and then you don't remember about connecting the components in series and parallel, oh, I want to tell you that you might think that electronics is difficult. So it means that we may join different electronics components either in series or what? Or parallel. Right? Because remember, if you want to increase the value, in case of resistance, connect them in series. If you want to reduce the value, connect them in what? In parallel. Class, are we together? This is the example. This is the example. Why? So this is the answer. Why? This is how we learn engineering. We don't, just, I told you, engineering is all about what? Numbers? Eh? Pardon? Graphs? Diagrams? Eh? Equation and what? And formula? Tables, right? So if we talk in terms of numbers, that is all about what? Engineering. Anybody who did not take this class and listen what I've been saying, he or she will not understand about what you've been writing there. Is it? Yes. Yeah. And that's why that you have to participate. So this is just a simple example. So this is, let's say, calculated. Let me just give you some information. Calculated value of resistance. So write down this example. And it's the same applied for capacitors, same applied for diodes, same applied for inductors. Right? Eh? Okay. So if that's the case, then we say that we may join different electronics components and whatever. Another concept which I wanted to teach you today, before I draw the schematic circuit diagrams that you have to implement in simulation software, is about something we call it in electronics, testing points. Say, class A, testing points. Again, say loudly, testing points.
Testing points.
Electronics, schematic, circuit, diagram. So testing point, it's just like bus stations along the road. So testing points of electronic schematic circuit diagram. Testing points is just like what? A bus stop. For instance, you are taking Daladala or Mwendokasi from Kivukoni to Kimara, and it's not express Mwendokasi. How many bus stops are there? A number of them. So those bus stops are very important. If your destination is Kimara, those other bus stops actual, they are not important for you. But if your destination is at Magomeni Mapipa, and then the bus does not stop until Kimara, ask your neighbor, what will happen to you? So that's the simple philosophy you should build in your mind about the testing points. We say that in order to measure, testing point is very, very important. So testing points, we say that, let me just define what does it mean, and then I'll tell you that where does they come from. Testing point, class A testing points. So testing point, we say that is the point along the schematic circuit diagram whereby the measurement of electrical parameter may be taken. So testing point, this is the point. Say point. We taught you, listen. You know that when you hear the concept that called the point, for me, I just went back to my basic mathematics Form 1 in 2004. 2004, I was in Form 1. Ask your neighbor, where were you in 2004? Where? Don't just ignore his or her response. So stop writing. Stop writing. In basic mathematics Form 1, one of the interesting subjects, one of the goodness of that subject, first of all, that subject had 11 chapters. 11 chapters. The first one is called what? Numbers. The second one is called what? Fraction. The third one is called what? Units. The fourth one is called what? Approximation. The fifth one is called what? Geometry. That's what I was looking for. Say geometry. So in geometry, we taught you about what? Point. We taught you about what? Line. We taught you about what? Line segment. We taught you about what? Acute angle. We taught you about what? Obtuse angle. You forgot them. Tell your neighbor, unfortunately, you forgot important information. So because you forgot the concept of point, today you see the applications of what? A point. And also in vector, for basic mathematics Form 4, we should see what? The second chapter. Okay. In vector also we talked about what? Point. Right? In space vectors, we talked about what? Point. So simply, this is just nothing. It's a point along the schematic circuit diagram where the measurement of particular what? Electrical parameter may be what? Taken. So as a mechatronics engineer, if you want to be a practical mechatronics engineer, and especially in the part of electronics, you have to be competent and you should have the skills and knowledge on how to choose the best testing points. Let me just remind you about the previous concept which we taught you in physics Form 4, especially physics Form 3 and Form 4. We taught you about how to draw the graph, especially in practical physics. Right? The graph might consist at least 5 points. Right? And those 5 points may be spaced in different positions of XY plane. Right? How can you draw the straight line or the graph? We taught you that you should choose what? The best points that fits what? The line. Or you have to join the points which are lying in the same path of what? Of the graph. So, some of the students, they are just watching me and then say, sir, what are you saying? You're just sending us back to O level. We are no longer in O level. Okay, fine. But you talked about the voltage and then see maybe against the resistor. We may have a point here, we may have a point here, we may have a point here. Then we use this way to notate them. Let me just remind you. Then how many lines you can draw there? Hello? Hello, it is still afternoon. It's not evening. It's not night. Some of you, you just have what? The mattresses in the class. Class, how many lines? So you can draw either lines that passing here, right? You may draw a line passing here. You may draw a line that's passing this way. Or you may draw a line passing this way. You may draw a line. So you have a number of what? Of lines, right? But we told you that you should choose what? The best line. So the matter is not to choose any point. The matter is you have to choose the best point which are meaningful. Are we together? Yes. Okay. So let us acknowledge about your course. In order to do measurements of different electrical parameters. Different electrical parameters. in schematic circuit diagram. The best point or the best testing points must be chosen or chosen. So it means that before you choose the instrument, the proper measuring instruments, you have also to think about the proper or the choice of the best testing points. Because the issue is not the instrument. Where are you going to measure? Where are you going to connect in your circuit? Are we together? Where are you going to connect in your circuit? So the choice of the best points give you the response on that. Are we together? Are we together? For the simple circuits, we just try our level best to choose any testing point. But for the complicated, we may ignore some of the testing points because maybe the information that we are going to measure is not important. Are we together? Are we together? So today, I'm going to teach you about series, parallel connection, and what? Choice of the testing points. Remember that when you've been given a schematic circuit diagram, the designer might not show you the best testing point, the best testing point, right? But I have to teach you the skills and knowledge about what are the testing points for this circuit or for the particular circuit. Are we together? Are we together? Yes. Before I continue, in case there is any question, ask it. And while you are asking the question, you may stand up. All of you stand up. Let's continue. So let us have, I will just draw the schematic, one of the schematic circuit diagram without the choice of the testing point, and then we'll be choosing together. Right? Then we'll go for simulation software. Are you ready for that? Yes. Okay, let me draw a simple schematic circuit diagram. So this is a schematic circuit diagram. Schematic circuit diagram of 40 of series, parallel, network. But we put in bracket without testing point. So remember that always in electronics we need power. In electronics circuits or electrical circuits needs power in order to work. That's what you have to think. So let us, as I say that, let us start with the simplest schematic circuit diagram. So this is the scissors. Here we are going to have, let's say, supply voltage. Then here we are going to have resistor. This we call R1. Then here we are going to have a light emitting diode, which is a semiconductor device. And this one, let us say that it's ready, LED. Then here we are going to have a network. Going to have a network. Here we are going to have a resistor. This is resistor 2. Then here we are going to have another light emitting diode. And this one will be green LED. And also here at this junction, we have again another resistor. And we are going to have what? Our light emitting diode. Check your neighbor if he or she is drawing. And check your neighbor, is he or she drawing by using a pencil or by using a pen? Check your neighbor. And then help me to tell him or her. Make sure next time you have a pencil. So here we have a common ground. This is the common ground. And here we have figure what? Figure 1. Once you told your neighbor to come with a pencil, he or she is making noise, eh? Of series parallel network. So this might be a general, say general schematic circuit diagram. Why do we call general schematic circuit diagram? Because we just have a schematic circuit diagram without the specific value. Hello? Without the specific values. We don't know the value of the battery. We don't know the value of resistors. We don't know, yes, in case of LEDs, that's fine. So this one, we might call it diode 1, and this is diode 2, and this is diode 3. And here we have R3. So while you are finishing up, you are drawing, let me clean this part. May I clean this part? Yes. Ah. Have you finished? Yes. Eh? How many components do we have here? How many components? How many components do we have there? How many? 8. Eh? Mention them. Eh? Wire. Is the wire a component? A wire is not a component. The first one, good try, but it's not a correct answer. The first one is? Okay, mention it loudly. The first one is? This is better. And the second one? Eh? Resistor. The first resistor. The third component? First diode. Ah, now you follow me. The fourth one? Second resistor. Oh, those are Bongolan students. The third one? Eh? That's the fifth, yeah? Second diode. This one. Then? This is the seventh. Eh? Number 7. Third. First, second, third, fourth, fifth, sixth. Right? The seventh? Eh? Diode. Remember that ground is just the negative terminal 40 of the battery. However, that in simulation we used to have 40, a ground terminal also. So we have how many components? Eh? Okay. So this is still general schematic circuit diagram. But with this is general schematic circuit diagram, we may also choose the testing point. Some students are busy. It's no longer time for drawing. It's a time to listen and understand. Then we draw what you have understood. So let us be specific. So you may draw this one. If I could be you, if you have drawn this one, I would draw the second one with values. And this one we just write the schematic circuit diagram of general series parallel network. So for you, you'll draw the second one, right? With these values. So the supply voltage, in order to have values and to do the measurements, that's why I'm trying to be specific. It's 9 volt. And then R1, it's 470 ohm. Then R2, it's 10 kilo ohm. Then R3, this is equal to 1.1 mega ohm. So now our schematic circuit diagram is no longer general. It's specific. Right? Are we together? Yes. So if that's the case, we say that choice. of different testing points. Choice of different testing points in figure 1. Okay, so now stop writing. Stop writing. So we are going to choose the testing points. And in those testing points, we are going to use measuring instruments to do the measurements. So, listen. Remember that most of the measuring instruments that I've told you, they just have 2 wires or 2 connectors or 2 leads. Right? 2 leads. So, I told you that it's better actually that to make a choice. So let me just redraw figure 1. So here we have resistor 1. But we forgot something here. What did we forget there? What is missing? Very good. Congratulations. So let us congratulate you. The answer is right. Let us congratulate you. 1, 2, 3. Okay. Imara. Wow. Good. So we forgot a switch. So here we should have, we may have a closed switch or not closed switch or an open switch. So we have our switch here. So the switch make a component number what? A? 8. Switch. So stop writing. So this is supply voltage, which you say it is 9 volt. Listen. The first testing point, even before you continue with other part or with other parts of this schematic circuit, stop writing class. It's this one. You have to be sure that the battery you are using provide 9 volts or it's not providing 9 volt. And especially for the hardware implementation, because when you use the battery to power your circuit, when you are using it, actually the voltage decreasing. Right? So the first measurement point or the first testing point, it's this one. Where our interest is not to measure current, our interest is actually to measure voltage. So simply, this we may call our testing point A. I said stop writing, look on the blackboard. Then, we come. So, okay, we are sure that our voltmeter actually that gives us 9 volts. In case we don't have 9 volts, we have to work on this battery. Then, here it's resistance 1. This is R1. And then the resistance is what? 470 ohm. So here we are going to have asthma. Here we are going to have a secondary testing point. And the second testing point for this case, we say that we need to know voltage across R1, the potential drop across this resistor. So this will be our testing point B. You may either put point B here or here. There's no problem. Are we together? Are we together? Are we together? That's our secondary testing point. According to this schematic circuit diagram, because it is DC, our interest is 2 parameters, right? Voltage and the current. DC voltage and the DC current. So in this network, here we have something we call it an electrical junction. Say junction. Say junction. And then what happens to the junctions? We have to remember about first Kirchhoff law, right? So the first Kirchhoff law, we say that here we are going to have total current. At this junction, we are going to have current 1. And at this junction, we are going to have current T2. And this is the directions of 40, directions of current. Okay? So here, another testing point, we need to connect the ammeter. But in most cases, I got the resistance values, we need to connect the milliammeter. Okay? Okay? According to the values of 40, resistance. Then, so this will be our testing point number what? The steady testing point. So this one will measure total current. Right? Then here it's the junction. So in the junction, we have R2. Here we are going to have another testing point. What is our interest? A voltage, potential drop across R2. So this is our testing point T. Okay, Asma? Then we are going to have what? A diode. A light emitting diode. Say light emitting diode. Ah, there I forgot a light emitting diode, and then you don't remind me. Do you see that you are not there? I forgot this light emitting diode in this series connection. Ah. Because the diode should be connected before the junction. Okay. So then here we have our ready LED. This is our ready light emitting diode. And then this is another testing point. V across diode 1. This is diode 1. Are we together? Eh? Now we are at the junction. So let me write this one for my friends here. Then, here we are. We have what? R2. What is the resistance of R2? 10 kilo ohm. And what the potential drop? So we need V across what? R2. So this will be testing point number. This is D. This is letter what? E. Then we have what? A light emitting diode. Remember this we said dot red, eh? Eh? Light emitting diode. So it emits what? It emits light. So here we are going to have another testing point. So the students may say that, oh, I'm confused there. I'm confused. You are what? I'm confused. Why are you confused as engineer? I'm confused there. So this is diode 2, which it is blue. Here we are going to have another testing point. And our interest here is the voltage across diode 2. Why am I measuring the voltage across R2? Because first of all, the resistance of resistors which have been used are different. And also, the potential drop across different LED with different colors is different. Are we together? Yeah. So don't say that, because I've measured voltage across D1, I assume VD1 is equal to VD2 is equal to VD3. That's wrong. Are we together? Are we together? Yes. So this is point 20, testing point F. Okay? But again, this is the network. So if this is the network, we want to know I1. Want to measure what? I1. We will be using what? Milliammeter. This is testing point 20. A, B, C, D, E, F. Then what? G. Then for this case, we are going to have our common ground. Okay? So then we come back to our junction. Then here we are going to have what? R3. Huh? So R3, what the resistance of R3? 1.1. 1.1 what? Class A, 1.1 milliampere? Mega ohm. So this is another testing point. V across R3. Huh? Then we have another LED, light emitting diode. Huh? So this one is emitting what? Light. Huh? Then here we are going to have, this is E. A, B, C, D, E. F, G, what? H. Your neighbor has forgotten the alphabet. A, B, C, D, E. V, here we need to measure voltage across D3. Now the 3. And this is the testing point. What the letter of that testing point? I. Then we need what? The current. Milliammeter. The letter of this testing point is what? J, yeah? A, B, C, D. Now you are telling your neighbors that you have retired, yeah? But 20 years ago, you have been a candidate of that song. This is J, yeah? A? And then here we have what? Our common ground. So how many testing points do you have? Thomas is Thomasing. How many testing points do you have there? Hey! How many testing points do you have there? 10. Even counting. 10. Sure. First. Then. Then. 10. Did we forget any? You have I didn't give you a chance to ask a question. You have not understood. Yes, I didn't provide the chance for you to ask a question. Just wait. So this one we say that the schematic circuit diagram. If you have a question, just wait. The schematic circuit diagram of series parallel series parallel network with what? With testing points. Okay, have you understood? Class, have you understood? Yes. Is it clear? Yes. Remember that these are the testing points for the simplest circuit diagram. That's why we have been paying attention on each point. If you have a complicated schematic circuit diagrams of more than 20 electronics components, we have to ignore some of the testing points. Otherwise, we will never finish to build up that system. Are we together? But the goodness of this choice of the testing point, it means that you will be actual testing each point of your schematic circuit diagram. Are we together? Are we together? If you'll be asked about the currents, maybe the total currents, you just see, you have this testing point. You have been asked just the current flowing through diode 2, you just have it. If you've been asked to maybe the voltage across R3, you just have it. Because we usually used to do it. I say it, it's time to watch and listen. Listen. We usually use to choose these testing points in case of calculation. Right? So in calculation, you may use the formulas, Ohm's law especially, and the first Kirchhoff law in order to do what? Calculations of different parameters. So we are very good on calculating. That is what we taught you in fundamental and advanced physics. Right? So in university level or in engineering level, we have now to teach you how you can use the measuring instrument to do what you have been doing in your paper work. Class, are we together? In a hardware implementation also, you will give the task of measuring the current flowing through this point. You will give that task a milliammeter, and then it will work for you. Okay? But because you have the theory, you may do the calculation. Only one of the limitations you don't know is the resistance of these LEDs, right? But if you know the resistance of these LEDs, you may do your theoretical calculation and then verify them in simulations and the hardware implementation. Class, is it clear? Yes. Okay, time for questions. Bina Mungu has a question. Listen the question. Don't write first.
Okay, the question is like this. Why these two, the first phase before the junction, you measured current before the diode, but these two phases, you measured current after the diode.
Okay, thank you. Binamungu asking a question about the choice of the testing point letter C and testing point letter G and letter J. That's your question. His question is like this one. Hey! His question, listen. So his question is, why did we choose this point as a testing point before the diode? But for this network, we chose point G after the diode. And for this point, we chose point J after the diode. That is his question. Who can answer? Who can try? Mavumba? Yeah. Yes. Thank you very much. So Mavumba replied the questions properly. The matter, because this is, remember that in case of ammeter, the ammeter is going to measure the current flow. For instance, this one. This milliammeter will measure the current flowing from this point to this point. So it's not important that maybe you put, maybe you choose. You may put the milliammeter here. We may put the milliammeter at this point. You may put the milliammeter at this point. You may put the milliammeter at this point. You may put a milliammeter at this point. So when we say that we are connecting the milliammeter in series, we don't have the principle or the guidance that whether we have to connect the milliammeter before the diode or after the diode. That's what Mavumba has said in brief. Right? Another question?
The question is that, in that case, we are coordinating some bulbs and the choice of wire, just wire, the wire that are made in our houses, or the institutional buildings, use power connection. So how do that buttons to make them in power or in series? And then the same factors are required on it, electrical components.
Okay, his question is, actually Mavumba is asking a question. In introductions of this workshop 8, I say that there are some reasons which actually make us to connect electrical or electronics components either in series or parallel or series parallel, right? So that's what I have told you about the calculated value of resistance and the standard value. It's just one of the reasons. There are the number of reasons of connecting electronics and electrical components either in series or in parallel or in series and series what? Parallel. Are we together? Because he said maybe for this one we've been looking at the standard resistor. Maybe you've been using just the we want to achieve the calculated value. How about diodes? That was his question. How about diodes also? We follow the same principle that we connect them in series or in parallel in order maybe to achieve the value that we wanted? No. Okay, so is it clear? Okay, it's time for writing. Then, okay, so once you have finished it to write, then it's time for us to go to the computer and draw figure number 2 and do the measurements, all the 10 what measurements. And it should represent your results in table. We said engineering is all about what? Numbers, formula and equation, diagrams, like that one, tables, and what? Graphs. So in next workshop, I will teach you about how to use the oscilloscope to visualize different waveforms. So stay tuned, and you have to make sure that you attend all the workshops that have remained, because the good news is coming. Is it clear? Okay. So students, let us go now to the very important part of of actual using our computer with the simulation software that called the Proteus in order to draw our schematic circuit diagram. So for the online students, I would like to ask you that this is the practical part. So you should have your computer ready and the software should be installed. So it's not important for you to watch the entire video and then you start to practice, but you may just check one thing or one action that I'm going to do, and then you stop the video and you practice yourself. Then you continue. So the goodness of the video, you may stop it and then practice. Once you succeeded, you keep on watching the video. Are we together? Class, are we together? So I have the simulation software that called the Proteus. This is the setup, or this is the desktop shortcut. And I have told you my students, and I'd like to repeat to tell you again, students, I ask you attention. Make sure that whenever you are opening the Proteus setup, whether in desktop or whether in documents or wherever it is, you have to make sure that you run it as administrator. Why do you need, or you are supposed to open Proteus software and you should run it as administrator? The reason is this one. If you ignore to open that Proteus simulation software or Proteus suites, if you ignore to open it as an administrator, if you visit the library, you may find some of the components have been missing. Students, I ask your attention. I ask you to watch on the blackboard. I know that you are expert on drawing what I have taught you. But listen, I'm adding value on what I've taught you. Let me repeat. This is the challenge that we have experienced. If you open the Proteus simulation software, in sometimes when you open it and you run as a simulation, then once you visit its library, the libraries of the components, you might find some of the components are missing, and especially if you are connected with internet. So our advice and my advice, make sure that when you open the setup or the Proteus software, you have to make sure that you run as an administrator. We don't have any more explanations about why if you open it, normally it misses some library, and when you open as an administrator, it actually has those missing components. Sometimes the components might be there, but you don't find the active component. You may find the device component. Are we together? Are we together? So that is safety and the precaution of simulation, especially using this software. So tell your neighbor, safety and precaution, run Proteus simulation software as an administrator. Tell him or her. I believe your neighbor did not understand what you have been saying. Repeat it again.
Safety and precaution, run Proteus as an administrator.
Okay, so let us run as an administrator. Then let us accept it that for this one, if there are the installations or whatever, we have just to wait for a while. What are the names of this window? Students, I told you that look on the blackboard, please, and listen. What are the names of that window? You forgot. It's called the home page. Then, let us create a new project. So, I taught you different ways that you can open or you can create a new project. And then let us name our project as what? As testy points. Then make sure that the extension file is there. Then it will be saved in documents. I don't need it. I just want this one to be saved in desktop. I have a folder that's called the Proteas. So it's better for you to select the appropriate folder where later on we'll just check your design. So then we have been prompted that we need to create a schematic capture. The answer is yes. Then next, do we need to create any PCB layout? We don't need for this time. So we have to click next. Then do we have any firmware? We don't have. Then we just want to open the schematic capture. That's all. That is the first step among the 7 steps that I told you. The first step to create a new project or to have a drawing paper. Are we together? Please check your neighbor. Some of your neighbors are sleeping. Then we are going for this. So students, what the second step? What the second step? You forgot until you review your exercise books. While I taught you for more than an hour about the 7 steps that you have to follow on drawing and simulating the schematic circuit diagram in Proteas. You forgot. I know that you should refer. So, if that's the case, then we say that fine. So the second step, we ask you to pick pick electronics components from their library, right? So then we are going to click these buttons of P. It's a first letter for pick. Then we have to refine our mind. What do we want to draw? We know the schematic circuit diagram. The first component is what? Battery. So you have to search the battery in the keywords. So just write battery. And you have to be careful. When you write battery and then you don't see the active battery, you have to stop and just go and restart your Proteus simulation software setup. Brother there, brothers there. In the second row. You're not listening. Let me repeat. Sometimes, for instance, today when I was preparing this workshop, I did this work before I come to teach you. Regardless that I did it last week, that is last week. In electronics, last week it's the last week. This week it is this week. Yesterday it is yesterday. Today it is today. Are we together? Are we together? So I ignored it to open what? To run the simulation software as administrator. When I wrote the battery there, I didn't see the active battery. I just saw what? The device battery. If you choose the device battery, remember that it will not give you the voltage that you want. Are we together? Okay. So those are the signs that will give you indication. Because sometimes you say that, this circuit, I drew it in the 6th week. I drew it myself. What's going on? Oh, what happened? Oh, my computer is not functioning. Oh, Proteus is actual that is complicated. Oh, it has been confused. No, it's you. So then let us choose these components. So we place in what? Object selector what? Object selector window. The next component, resistor 1. No, the switch. The switch, I told you that is single pole, single throw switch. I taught you the shortcut of searching the components quickly. Are we together? Yes. Then again we have, if you see this switch, it's been written active. If the Proteus did not open it well, when you search the switch, you won't see that active switch. So the indicator that maybe you have done some mistakes on opening, just on opening the software, is in case you are missing some active components that you know in your mind that they should be active. Are we together? Are we together, class? Yes. Okay. So let us pick it. The next component is what? Resistance 1. What is resistance? 407 R. Then we choose in the category resistor. Then we choose 0.6. Then here it is. Quickly. Then the next component is what? A ready light emitting diode. So you just write ready, then you put slash or dash, then you write ready. That's what I told you, that please stop doing what you are doing. Follow, listen, watch. I'm teaching you shortcuts of drawing that schematic circuit quickly as well as possible. Because the library of LED contains more than 10 LED. Until you say this is red, you spend more than 2 minutes. Right? So you just write ready, you put dash, you put the color. It's ready. So there it is, and it's active. If you choose device, that's for the schematic purpose. So did we select it? Not yet. We have placed in there object select. Because the goodness of this wizard, actually, when it opens, you still have object selector window. So in case that you choose anything, you have to make sure that it is already there. Because you may not use in drawing or editing window if the component is not there. Are we together? The next component is what? A resistor with resistance of 10 kilo ohm. Is it? So you just write 10 kilo ohm. In category, then you scroll down, you have to choose resistor. Then we need 0.6 watt as a power rating. So there we see 10 kilo ohm, 0.6 watt. We see 110 kilo ohm, 0.6 watt. We see 510 kilo ohm, 0.6 watt. And then we see 910 kilo ohm, 0.6 watt. That's the power rating. So we need just a resistor with a resistance of 10 kilo ohm and a power ratings of 0.6 watt. Okay? The next component. Class, the next component. My classes have been lost. Lady, then dash, blue. The next component is what? Light emitting diode. Blue light emitting. Say blue light emitting diode.
Blue light emitting diode.
Yeah. So there it is. Just lady, then blue. So my ear. Then this is. Right? The next component is what? A bridge. A resistor with resistance of 1.1 mega ohm. So you just write 1. I taught you all the resistors with the point or with the decimal point. We used to write the whole number, and then we used to write the value. Then we used to, that means the decimal point will be represented by the letter. Then the next number, which we call the decimal points, will be written after the letter. So I taught you that in case of resistors, if you have a resistor with the decimal point, you have to write the whole number, then the letter, which is the actual what is the SI unit or the unit, then the decimal point. Right? So there we have 1.1 mega ohm. What are we going to write? 1 M1. Those are the shortcut. Otherwise, you may spend a week to find 1.1 mega ohm. You may say, let me use 1 mega ohm. So 1 M1. Then you have been asked about what? The power rating. So the power rating today, we don't have 0.6. So if you don't have 0.6, that's fine. Let us take what? 1/10 watt. So 1/10 watt, we have our high power resistor. You see here, 1.1 mega ohm. So we place there. The next component is what? A green. Green dash light emitting diode. Did there? Did they write a did they do? I messed up. Lady dash green. So you see that if you mix up, You don't see what you have been expecting. Green. So there it is. And it's active. Right? So let us select it. Do we need any other component? Do we need any other component? No. So we are done with the second step of picking the electronics components from what? The library. We are going for the SEDI, so we click OK. If you are done, just click OK. Then we are going for the SEDI step. What the SEDI step? Because I know that one of your hand, it's on the previous what? Workshop to read the third what? Step. So the SEDI step is what? You should not claim them. You should not write. This is your business. This is what you love. This is what you have been studying for 4 years. Keep in your mind. What do you keep in your memory? Because you don't keep the contacts. You don't keep the phone numbers. Because you have the memory there. So even the 7 steps. 7 steps. How many days in the week? 7 days. 7 days. How many days in the week? So you kept it. We have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's all. You need to write somewhere. Oh. Okay. So let us, the SEDI step is what? Place what? Electronics what? And what? Okay. Fine. So, the first component is the battery. Here it's a battery. You can zoom out. Here it's a battery. The default voltage is 12 volt. We have to work on that. Go to a schematic circuit. Do we need what? We need 9 volt. So we have to right click it. And then we add the value. Instead of 12, we are going to have what? 9 volt. Then okay, we have a battery of 40 of 9 volt. Right? The next component is what? Single pole, single what? Single pole, single throw, switch. The next component is what? 400 and what? And 70 ohm. Right? The next components that you have to place is what? Ready light emitting diode. Here it is. So then we rotate. Right click, then rotate anti-clockwise. Then we need to drag it to align in the same line with the lines of resistor. Right? Yes. Then the next component is what? 10 kilo ohm. So 10 kilo ohm. So here it is. And then let us rotate. So you may either resistor does not have polarity. You may either rotate it anti-clockwise or clockwise moment. Do you remember that when did we teach you for the first time about clockwise and anti-clockwise moment? Physics Form 2. And that was the principle, right? The total clockwise moment should be equal to the total anti-clockwise. You have been a good physicist by that time. But nowadays, we are retired engineer. Wonderful. Then another component is what? Blue LED. Green, blue, light emitting diode. Then the next component is what? 1 mega, say 1.1 mega ohm. Say 1.1 mega ohm. Then check your neighbor. Is he or she happy? Okay, the next component is what? Green LED. Are we together? Do you still have any components? Do we still have any components that we didn't place on the drawing window? No. Then we have to go back to the second step. Where, because in second step, we have to pick electronics components from the ear library and the measuring instrument from the ear library. Are we together? How many testing points do we have? 10. 8 testing points, no, 7 testing points will help us to measure voltage, and the 3 testing points will help us to measure what? Current. Right? So which measuring instrument do we need? A? Wrong. What are the measuring instruments we need there? DC milliammeter, and the DC volti. Simple like that. Where do we get them? In icon number what? 14. On your right hand side. It has been written as what? Visual instrument mode. So let us go there. So for the online students, you may stop a video and practice each point or each part that I have been doing. So we are going to the second step where we are going to choose what? Our measuring instruments and place them. So the second step and third step we have to do for the electronics components and we have to do for the measuring instrument. Are we together? Are we together? Are we together? Okay. So the first measuring instruments, as I told you, DC what? Voltimeter. DC voltimeter. First one, we need to be sure. Is this 9 volt? Right? The second DC voltimeter that we need a voltimeter across what? 470. Right? Another point that we need voltimeter that will measure voltage across diode LED1 or red light emitting diode. Right? Then we need again voltimeter to measure voltage across R2. Again we need what? Voltimeter to measure voltage across what? Across a blue light emitting diode. So as long as in your cursor you have the DC voltimeter, you have to place in different points. You have to redeem your time because later on we'll be dealing on simulating complicated schematic circuit diagrams of electronic system. Okay? Are we together? Okay. So then next, so for you, because it's your first time, it's not compulsory for you maybe to just to do it quickly as I do. You may just do one step after time, but do much practice. Right? Then we need again another DC voltimeter to measure potential difference across this what? Across a green light emitting diode. So I think we've placed all the 7 DC voltimeters, isn't it? Yes. Check your neighbor. Is he or she concentrating or? Then we have our what? We have to take our DC ammeter. We'll place a DC ammeter, but we have to change the configurations to have DC milliammeter. Why DC milliammeter? Because for me, once I have a resistance of 1.1 mega ohm, I know that the resistance which will be flowing through that network will be very, very, very small. An ammeter cannot measure it. Are we together? So every choice of the instrument should have a logic and reasons in your mind. So we have our DC. I told you that you can place anywhere. This will measure total current. Right? Then I told you that it's better for you to do any kinds of adjustment in advance. So in order or in display range, let us choose what? Milliampere. Then we have it. Then we need to connect an ammeter where? We need to connect an ammeter here. So then you rotate it. Then we have to change its what? Its properties. We need to have what? DC milliammeter. There it is. Then we need also to have. You may also say that, for instance, here you have it. You may also use this icon of, we call it block copy. Do you see that icon? Hey! Look there. The icon is written what? That icon gives you the functionality to copy the same instrument, especially after you have edited its properties. Are we together? Yes. Ask your neighbor, do you love mechatronics engineering? Ask it here. Ask him more high again. Do you love mechatronics engineering? Some of the neighbors are not asking their neighbors. Why? Don't you assume that they love? Possibly they are very, very hungry. So this one, we can use this one. Once you click block copy, so you see I have now a DC what? A DC milliammeter. I have just copied it and move. Are we together, students? Yes. Okay, this we call them expert shortcuts. Okay, so then we are done with the second step on the measuring instrument, and the third step. We have chosen what is the measuring instrument from their library, and we have placed them, they said place them on drawing or editing window. Are we together? The first step, we have to rearrange. We have already rearranged according to a schematic circuit diagram. So we skip that one. Right? The fifth step, we have to connect them, right? We have to wire them, right? Yes. We are going to wire the components first. Then we come to wire the measuring what? Instrument. So keep watching, keep practicing, and keep enjoying. Okay. So then, in case of so this is for the block move. If you want to move the block, and this is the battery, you can either drag object or you can use that icon quickly. So here it's our battery. Then for the ammeters, we'll join them because we have them. Then join one terminal of DC milliammeter with a switch. Join one terminal with resistance 1. Join that terminal with LED. Then join that terminal with what? With this DC milliammeter. Join that terminal with R2. Join that terminal with what? With blue LED. And then join this terminal with green. Then here it is. This is our junction. Join this terminal with this one terminal for DC milliammeter. Then join this terminal with this terminal. We forgot one of the important part, which is ground, right? So where do we get it? In icon number 8. In icon number 8, which is written as what? Its name is what? Terminal mode. So we choose ground and place it there. So then, fine. So you may say that, okay. So now we have our network here. Then we are going to connect with our ground. Then connect the ground with what? With the negative terminal of the battery. So did he finish to wire our component? Did he finish to wire our electrical or electronics component? The answer is no. I did not ask about wiring the measuring instrument. I asked about the components. Oh, so it seems like you don't love this stuff. So you can move this block if maybe you want to move it some few steps, and then you can move also this one some few steps if you like it. Then you have your circuit like that. You are allowed to do any kinds of the modification. Now we are going to wire our DC voltmeters, right? So let us start with this one. We connect it, this positive terminal of DC voltmeter with the negative terminal of the battery. Then we join the positive terminal with this point. This is, so remember that this is testing point 20 A, right? Yes. Where the testing point B? This is our testing point 20 B, but it's not complete because this one has to measure the potential drop across resistance 1. So this is potential. This is testing point B, right? What's our testing point C? Check your schematic circuit diagram. What's our testing point C? It's an ammeter. It's a DC milliammeter, isn't it? Yes. Okay, so we have this one. So this is our testing point C, because we have to relate what we taught you in theory. This is our testing point C. Testing point, right? Then next is testing point what? D. So testing point D, it is between what? It's the potential drop across what? Light emitting diode. So for the light emitting diode, remember that this is art. This is actual art. So you should not limit it to have maybe a straight wire. So you may actually bend the wire in 90 degrees according to what you want to draw. You should not be limited. Are we together? Okay, fine. So then, so this is our point E, testing point D, right? Where is our point D? Point E. The next point is what? Point E. E. Where is our point E? Testing point E across what? R2. Is it? Testing point E across what? R what? R2. That is testing point E. Is it? The next testing point what? F. Ask your neighbor, do you love mechatronics engineering? Your neighbor is quiet, eh? Okay. So that is our testing point what? F. Right? Next it is what? Next is what? After H. That is H or what? This is H or what? F. Next is G. So testing point G across what? R3. Isn't it? Here it is. Then this one across this what? R3. That is point what? G. After G, next is what? H. H, right? H it is what? Check your schematic, your figure 2. You have it. We have already forgotten. Which one? Okay, anyway. And then ammeter it is point what? G. So we have an ammeter already, this one. This is the C milliammeter. Right? Yes. Just see the configuration, I've just changed because for reasons for diameters are in schema diagram diameter, I've connected them here, downstairs. As I answered the Binamungu's question. Don't care about where you connected the ammeter. What you have to care, it's within the correct network. You may connect the C milliammeter before a resistor, or in between resistor and the LED, or after LED, but within the same network. Are we together, students? Yes. Are we together, engineering students? Yes. Then we are going for the last point here. This is the point, and this is the point. Because remember that before we have the measuring instrument, when we simulate our circuit, at least the LED actually give the visible light. We can see that, oh, my circuit is working because the LED is on. Can you imagine what if you have semiconductor components which don't give light? How will you know that your circuit is going to work? Or it has been working? That's what I told you, that you as mechatronics engineer, you have to like numbers. And you have to present or explain any of the concept or any of the information in terms of numbers. Are we together? So have we finished the step number 5? Did we connect all the electronics components? And we connected with the measuring instrument, Let us go step number 7, step number 6. Step number 6, run the what? How are you going to run the simulation? We press the run button. We press the run button. So let us press. Did I press? Yes. I pressed there. What the challenge? We didn't turn on what? Switch. I know for the most students who are against the mechatronics engineering, once they hear that we are going to run the circuit, you know the year prayer is what? For the circuit not to run. So for those who have been praying, say, yes, today the circuit is not running. The circuit is not running. Our teachers asking us, do you love mechatronics engineering? Now, mechatronics is mechatronics. Things are not running. So students, celebrate that. And it's good if you have the positive intention. But if you have negative intention, that's bad. Okay, so let us turn on the switch. Turn on what? The switch. Once we turn on the switch, what do you see? Do you see the LEDs on? No. Why the LEDs are not on? The answer is very simple. Every light emitting diode has a minimum forward voltage that require for it to give light. I'm not teaching you about electronics device and components. That's not the intention of this module. But so you can write that note. Each light emitting diode needs minimum voltage that is called the forward voltage. Each light emitting diode needs a minimum voltage that is called the forward voltage. So if you give, or if example you supply the voltage which is less than, if the potential drop across the diode or the LED is less than the minimum, or it's less than its forward voltage, the LED will never give you light. Are we together? Yes. So the answer of that question, you have to check the potential drop across what? Red LED, the potential drop across what? Green LED, the potential drops across what? Blue LED. Are we together? Because for instance, if you don't want to do measurement, you will be surprised. I simulated the circuit, the LEDs are not on. What's wrong? Right? Yes. But with those numbers, you may give a reason. And actually, it is technical reason. Are we together? Are we together? Yes. So for instance, for the first for the red LED, the potential drop is what? 2.15. For this one, it's what? 2.15. For the other one, it's what? 0.49. Are we together? Yes. Then from there, how many measured parameters do we have? How many measured parameters do we have? We have 7 measured voltage and what? 3 measured what? Current. Let us just pass through. Do we have any problems with our battery? No. What the potential drop across the battery? 9 volts. So it's providing 9 volt, right? Then what is the reading for the first DC milliammeter? 0.45 milliampere. Then what the potential drops across 470 ohm resistor? 0.21 volt. Then what is potential drops across the red LED? 2.15 volt. Then what the potential, the current flowing through the network of R2 and D2. What the current? 0.45 milliampere. If you have used the DC ammeter, you won't have those readings. Are we together? Yes. Are we together? Yes. Then what the potential drop across are 4.24 what? 9 volt. Then potential drops across the 2.15 what? Volt. Potential, what the currents through the network of what? Are 3 and what? And the D3. It is what? It is what? 0 ampere. Right? What the potential drop across are 6.14 volt. What the potential drops across the 0.49 volt. Check your neighbor. Your neighbor is not mentioning those parameters. Your neighbor is working hard on drawing that. And see if things will work on your computer. Are we together? Then let us refer first to Kirchhoff's law. How does the first Kirchhoff's law state? First Kirchhoff's law state that the algebraic sum of 40 currents at the junction is equal, or is what? 0. Is equal to what? To 0. So I is equal to I1 plus I2. Because you've been learning the first Kirchhoff's law. They've never known that where are you going to use them. This is the one of the point that you're going to use it. Right? So what the value of I total? 0.45 milliampere. What the so suppose that the network of R2 and D2 it's I1. What the value of I1? 0.45 ampere. What the value of I2, which is flowing through the R3 and D3? 0.00 milliampere. So if you take I1 plus I2 is equal to I, then first Kirchhoff's law has been proved in that circuit. Are we together? Yes. Class, did you understand? Yes. Did you understand? Yes. So let us congratulate ourselves if you have understood. 1, 2, 3. Ongera. Imara. Wow, especially for those who are slumbering. So now it's a time for you to practice, to draw and measure. Okay, so if you have managed, in case that you found some challenge on either picking the components or picking the measuring instrument, that should not be a challenge for you. Just watch this video several times as well as you can in order for you to make sure that you understand the concept. So I would like to ask you to practice and review these contents that we've covered today. In case you have any question, don't hesitate to ask in the comment section. But again, because we have our official, special, online Bachelor Polytechnics of Tanzania, that is actual online institution and Polytechnics institution, where we are training students about the Word of God, we are training students about electronics engineering, we are training students about mathematics, especially higher mathematics, and also we are training students about computer programming and special embedded programming. So you may also register yourself by just subscribing onto our channel. So if that's the case, I would like to say that for workshop 8, today it's enough. This is the end of workshop 8. The homework that I'm leaving to you, make sure that you draw this circuit at least 3 times and do the measurements. And this is the task I'm leaving for the physical and online student. Make sure that you draw a table of results. Students, make sure that you draw a table of results. And you present all the 10 measured physical quantities that you have measured. So we need a schematic circuit diagram. We need a table of results. Because you say engineering is all about numbers. It's all about formulas and equations. It's all about diagrams, like that schematic circuit diagram. It's all about what? Table of results. It's all about what? Graphs. So in next workshop, I will teach you how to use the oscilloscope. We can connect the oscilloscope in one of the points and see the nature of the waveform. And also the oscilloscope also can do the measurements. Just the oscilloscope can also measure voltage. Mostly can measure root mean square voltage, maximum voltage. The oscilloscope measures the maximum voltage. So that's the end of workshop 8. I would like to invite you in workshop 9. Share this good news to your friends, to your colleagues who love mechatronics, who love electronics. Tell them workshop 9 is along the way. You are warmly welcome. Thank you very much. I love you so much. May God bless you until we meet in the next session. Thank you very much.
Africa.